Welcome to the Cert Prep. If you new here, I am Gonju, and for me, best way to learn is to explain it to someone else. That is why I created this YouTube channel. I am currently working towards becoming a Certified Kubernetes Administrator, CKA. I feel that having a solid understanding of containers is essential for progressing with the CKA exam. So, in the first few steps, I will be covering some basics about containers. Imagine a few years ago, if you wanted to run an application, you'd need a physical server. You'd put the application on this server, and that's all it would do, run that one application. But the problem was, these servers weren't used efficiently. If your app only needed 30% of the server's power, the other 70% just sat there, wasted. Plus, if you wanted to add a new app, you'd have to get another server and go through a long process of setting it up. Then came virtual machines, VMs. Think of a VM as a computer inside a computer. With VMs, you could split one physical server into several smaller virtual servers, each running its own app. This helped use the server's resources better and added isolation. If one VM crashed, the others were still safe. But VMs had their issues too. They were heavy because each one needed its own operating system, and slow to start because they had to boot up an entire operating system. That's when containers came along, and this is where it gets exciting. Containers are like VMs, but much lighter. They don't need a full operating system, just the app and the dependencies it needs. So they're fast to start, almost instant, and they're way more efficient because they share the host's operating system. It's like giving each app its own little box to run in, without all the extra baggage of a full operating system. Imagine you're building a project on your computer that needs certain tools and settings to work. You might have installed special programs, libraries, or even specific versions of software to make your project run properly. But here's the problem. If you try to share that project with someone else, it might not work on their computer. Maybe they're using a different operating system, or they don't have the exact tools or settings you do. A container solves this problem. Think of it as a box that you pack everything into, your app, its settings, and all the tools it needs to run. This way, no matter where you send that box, your friend's computer, a server, or even a cloud service, everything inside it works exactly the same. The computer just needs to know how to open the box, and that's what Docker or Kubernetes helps with. What is Docker? Think of Docker as a tool that lets you package up your app, along with everything it needs to run, like libraries, settings, and files, into a special box called a container. Once your app is in this container, you can run it anywhere. On your laptop, on a friend's computer, or in the cloud, and it will always work the same, no matter where it's running. This is because everything the app needs is inside that container. Installing Docker is quite simple, but the process may differ slightly depending on your operating system. Installing is explained in the Docker's webpage, so please let me know if you need any issues on installation so that I can create another video if needed. I already installed Docker into my Ubuntu VM, so let's get started with some basic Docker commands. First, let's check if Docker is installed and running. Use the Docker version command. This will display the Docker version installed on your system. You'll see both the client and server versions. If Docker is running correctly, you'll see the details here. If not, you might need to start Docker or check the installation. Now, let's run our first container. The Docker container run command is how we start containers. For example, Docker container run nginx. This tells Docker to pull the nginx image, a web server, from Docker Hub if it's not already downloaded, and then start a new container with it. Once it's running, you have a web server inside a container. I have already installed nginx image before, so it uses that image when I perform run command instead of downloading it from the Docker Hub. As you can see, our session is all black now because nginx is currently running on the screen, but how can we make it run it at background? Let's perform Control-C and exit this process and see the current status of our Nginx container. Let's try Docker container ls. As you can see, there is no output for this command because Docker container ls is used to see the list of running containers. This will show you the containers currently running. If you want to see all containers, including those that are stopped, use Docker container ls-a. This will display the full list, both running and stopped. And here we go. Our Nginx container is listed under here. Now let's run our Nginx in the background while freeing up your terminal. For that, instead of stopping the container, we can simply detach from it. To do this, we use the docker container detach command. Let's run docker container run --detach nginx and see if we can see an output at docker container ls level this time. Okay, here it is. Next, we'll run the same Nginx container, but make it accessible from our computer's browser. By using the -publish flag, we tell Docker to map the container's port to our local machine. So, docker container run, publish 8080 nginx. This command publishes port 80 on the container to port 80 on your local machine. Now, if you visit localhost in your browser, you'll see the Nginx welcome page. As you can see, container names are some random names if we do not provide a specific name to the container. In this example, it is Nifty Sutherland. Let's add name option to change it. Here's what we did. We used docker run nginx command. This tells Docker to pull the nginx image, a web server, from Docker Hub if it's not already downloaded, and then start a new container with it. We use some flags to specify how we would like to run the Docker image. Publish 8080:80 maps the container's port 80 to our machine's port 8080. Name nginx gives the container a name instead of a random one. D runs the container in the background, detached mode. To stop a running container, use docker container stop command. This will gracefully stop the container, where you can use container ID or 3 digits of the container ID or name of the container. You can find the container ID using the docker container ls command. Finally, let's remove the stopped containers from the system with rm command. Okay, now let's try to remove the running containers from the system. As you can see, it is failed. We need to use the F flag to force this removal. This is our first video as an introduction to the containers. I will be covering it in more details, such as networking, process management, and images, before getting into the Kubernetes. Hope you enjoy this video and see you in the next one. If you enjoy this video and want to see the rest of the series, please make sure to like and subscribe to support my journey.